Now we have studied about P and N type of semiconductor. So what do we do with P and N? The possibility of existence of all the electronic devices in this modern age is due to semiconductors only, and especially the p-n junction diode, because with the effect of diode we were able to design triodes, pentodes, and finally IC circuit, right? So we are going to study about them. So what is a diode? Diode is a p-n junction assembly. We have one side P type and another side N type. Now we do not make this p-n junction diode like this. We take a P diode, we take an, sorry, not diode, we take a P semiconductor, N semiconductor and join them. No, it doesn't happen like this. Over P type semiconductor, N types is diffused in layers, or over N type, P type is diffused. This is how a p-n junction formation takes place. Now what exactly happens when we form a p-n junction diode? See, consider this diagram. We have a p-n junction diode like this, where one side we have high amount of positive charges with some small negative charges as well, which will be called minority charge carriers. We have already explained this. Consider again this diagram of N type semiconductor, which was doped with pentavalent impurity atom. Okay, what happened here? With addition of each impurity atom, we were getting an extra electron in the circuit or the void, due to which number charge density of electron is way greater than charge density of holes. Very well understood. But in addition to these electrons, all these electrons which were breaking their bond and coming out for the free state, they were creating some holes as well. So what happened? The charge density was way greater than the charge density of holes. That is why these were called majority charge carriers and that was called minority charge carriers, right? So there were two types of charge carriers in both P and N. The majority one which are present in more amount, the minority ones which are present in lesser amount. Okay. Now, right now I am not making those minority charge carriers in the diagram because it will be easier for you to understand in this way. And on the another side I have one N type semiconductor which is all negative. Okay. Now due to presence of the opposite type of charges in two different regions which are actually attached, these electrons are going to, or these charges are going to attract each other, because there are opposite polarities present here. So they are going to attract each other. What will happen now? Once they attract each other, they are going to fuse into one another, they are going to create a neutral region, right? So this creates a neutral region here. Now this neutral region is not going to stay like that, it is going to keep on increasing or expanding. Why? Because more and more charge, because all these charges are now free charge carriers, more and more charge will drift towards another junction or towards another region and they are going to get into neutral state. So this neutral region is going to keep on expanding. Now what exactly happening during the formation of this neutral region? This is called neutral or depletion region. Okay, because the charge in this region got depleted, depletion region, right? Now during the formation of neutral or depletion region, what exactly is happening here? When this charge, the negative charge which was going to neutralize with positive charge, it created a positive charge in its place. Though this all is now considered into neutral region only, but the assembly of charges is like this: positive gets accumulated on this side and negative gets accumulated in this side. So for any further charge to migrate from this region to that region, they have to bear the pressure of what? The pressure of repulsion of these accumulated charges. Consider this: any positive charge which wants to come into this region will be getting repelled by the accumulation of all these positive charges, and so is the case with negative charges. So there will be a point when the migration of charge from one region to another region is going to stop because of this repulsion. That is why this region, neutral or depletion region, is also referred as potential barrier, because right now this is working like an imaginary battery which is stopping the further migration of charge from one region to another, right? So called as potential barrier. I've seen this question a lot of times in the exam, that what is the difference between depletion region and potential barrier. Depletion region is the starting state of potential barrier. That means when a p-n junction diode is made into existence, the charge gets neutralized in the midway and they create potential barrier region or neutral region. Now that region starts expanding till the point migration of charge from one region to another is stopped by the accumulative polarity of opposite charges inside the neutral region. So when it is at its highest peak depletion region, it is called potential barrier. That's the basic difference, that potential barrier is made out of the neutral region itself. Alright, so potential barrier is also the name of neutral and depletion region. Now, so now it is clear to you that how potential barrier is formed. We did not make potential barrier, we just created a p and n junction diode, but this neutral or this potential barrier got created by itself. Okay, so due to this potential barrier, we have enormous uses of p-n junction diode. Why? Because it allows conditional passage of current. That is, consider a resistor. In case of resistor, current can flow in from either direction, but due to this thing, current cannot flow in the p-n junction diode. It can pass the current only in one direction. We are going to see how. So this topic is called working of a p-n junction diode, and working can also be known as biasing. Biasing means how we use a semiconductor diode. Okay, so even if I call it p-n junction diode or just I call it just diode, it means the same. So it is referred as, the working is into two states. One is forward biasing and another one is called reverse biasing. Before going into this detail, I am going to give you the symbol of a p-n junction diode. This is the symbol, a triangle and a straight line. This is the symbol of a p-n junction diode. This thing is P, this thing is N. The triangle part is P and the straight part is N. Alright, now in case of forward biasing, what do we have till now? We have a p-n junction diode which has a neutral region. This is P part, this is N part. Okay, when P part is connected to positive terminal of the battery and N part is connected with the negative terminal of the battery, this type of working is called forward biasing. I am making it a variable source. So what will happen? See, this applied voltage is going to oppose the potential barrier voltage, because they are into opposite polarities. So this region is actually going to shrink. This region will remain only till this much level. So there will be very easy flow of charge from one region to another. Now students do ask me this question quite oftenly, that sir, if the charges are now free to migrate from one region to another, so that will again create the existence of neutral region in both of the regions, right? No, it does not happen. Why so? Before the application of this external battery, the charges were moving from one region to another in presence of their own electric field, in presence of their own potential difference. But right now, this potential difference is diminished by external voltage, and now the charges are going to migrate from one region to another in the presence of, or in the effect of, this applied source, right? So once an electron enters this region, which is very easy for electron to go because the depletion region has shrinked, the electron will jump from hole to hole and it will enter this junction. It will come into the positive terminal of the battery. There a covalent bond will break due to the chemical reaction, and the liberated electron will go back in the N region. So the number of charge carriers remains the same. This is exactly what is going to happen with P charges or holes as well. So this is what forward biasing means, that depletion region shrinks and there is a very easy flow of charge. But in case of reverse biasing, as the name suggests, this is what we have now, a P part and an N part. Now positive terminal is connected with the negative terminal of the external source, whereas negative with the positive. This means reverse biasing. In this case, the external battery is, or external source, is going to support the neutral region, and this region will now increase. So what will happen now? The increased state of depletion region will stop any migration of charge from one region to another. But mind it that this is also the state of forward biasing for minority charge carriers, which I have not shown. Minority charge carriers are negative in this and positive in this. So these minority charge carriers are undergoing forward biasing only, so that means they are going to shift into other regions very smoothly, even with small application of electric field. But for majority charge carriers, there is complete abandonment and they are not going to go from one region to another, right? This is what we mean by reverse biasing, and this one was forward biasing. So in case of circuit diagrams, how do we show it? It's a very simple diagram. This one, P part connected to positive terminal of the battery, N part connected with negative terminal of the battery. Alright, variable source, that means the source is connected with a rheostat. If you want to measure the current, ammeter, If you want to measure voltage, then voltmeter. The characteristic during forward biasing or forward characteristics of a diode means a graphical relation between voltage and current. So the graph would be like this. This side I am drawing current, and this side I am representing voltage. So with increase in this voltage, there will be not much increase in the value of current till when? Till the point when the applied source has the voltage value greater than the potential barrier voltage. Obviously, because even if the source, suppose the potential barrier voltage is of 5 volts and the source is 3 volt, it is not going to overcome the value of potential barrier. Plus, it is not going to shrink that value, right? So when this applied voltage exceeds the value of potential barrier voltage, current increases linearly, almost linearly. So this point is called knee voltage. That voltage value in case of forward biasing of PN junction diode, after which current increases almost linearly. In case of reverse bias state, the circuit diagram would be same. PN junction diode connected with a source, but this time P will be connected with negative terminal of the battery and N will be connected with positive terminal of the battery. For current, ammeter; for voltage, voltmeter. This time if I draw the graph which is called reverse bias characteristics, this is current, this is voltage. I am not going to get any current or a very feeble current in case of reverse bias state. This current is so much feeble that we have to specially mention that this current is in microamperes and this current is in milliamperes. Alright, so this current is very feeble, and the existence of this current is that there were minority charge carriers which were present in both the regions for which the forward biasing actually happening, right? Now we have seen that current is really small even with the application of large voltage, but when we keep on increasing the value of voltage, what will happen? There will be a point of breakdown at which all the charge will surpass this potential barrier thing and they are going to flow in other direction accumulatively. So current is going to increase like this. Okay, this is called Zener voltage or breakdown voltage. So when this happens, this diode still conducts, but we do not want this type of conductivity from the diode. What do we want from diode? Diode should conduct very easily when it is forward biased. It should not conduct when it is reverse biased. So suppose this diode, which is having a Zener voltage of, let's say, 5 volt, that is in reverse 5 volt, it is going to conduct abruptly. So I am going to use this diode in a circuit where the maximum reverse voltage is not more than 3 volts, because I don't want this condition to go through. I want the diode to conduct very easily when it is forward biased. I do not want to conduct it when it is reverse biased. As simple as that. So these are the details for forward biasing and reverse biasing.